Okay, take two. We've got this quadratic function y equals ax squared plus bx plus c. And we've got a football player and a kicker. I like pictures even though I can't draw, so here's my football. If I was feeling fancy, I'd probably add a kicker. I can't draw, I don't care. We do know that we're going to have a parabola, a negative parabola, because it starts with a negative right here. They tell us that my horizontal distance is going to be x and that this is going to be my height right here. And they're asking me what is the maximum height of the punt, which is going to be at my vertex, which is going to be at x comma y. And there's a couple of ways to do that, but they asked us to complete the square, and you do have to follow directions. So if I was going to complete the square, I'd set it equal to 0. And I pray that my pen was working. So then I've got negative 0.01 x squared plus 1.18 x plus 2 equals 0 to complete the square. I'm going to move that 2 out of the way because it's not all involved in the craziness. So negative 0.01 x squared plus 118x plus whatever it is I'm going to end up using to complete my square equals negative 2. I am going to factor out that negative 0.01 because it's absolutely ridiculous. If I factor that, I've got 1x squared. I'll just write the x squared. And if I'm going to factor, this was 1.18. If I'm going to factor it out, that means I divide by 0.01, which means if I was multiplying, it would get smaller. If I'm dividing, it's going to get bigger. It's going to get bigger 2 decimal places to the right. And I'm factoring out a negative, so this has to be a negative. And I'll check that because it makes me crazy. So then we've got 118x plus whatever other thing I'm going to put there equals negative 2. And just to check, if I multiply a negative times a negative, I get a positive. And if I multiply 0.01 times 118, it gets smaller by 100. So that would be 1.18. So that's correct. Now I need to figure out what to add on both sides here. And I have to be careful with my signs. So it starts off with b equals my original b, or my b here is 118, because that's where I'm going to do it. And b over 2 is 59. And b over 2 squared, I've already done it, but I will show you on Wabbit. 118 divided by 2 is 59. 59 squared is 3481. So 3481, which is what I'm adding to the left side. But it is not what I'm adding to the right side. What I'm adding to the right side is 3481 times the thing I've factored out. Because if I was to distribute this back out to make the equality true, I would be having 3481 times negative 0.01. So I'm going to move the decimal place over 2 because I'm multiplying, and I would have negative 34.81. I'm going to add that here, minus 34.81. So on this side, I've got minus 36.81. On this side, I've still got the negative 0.01. And it's very easy to factor this because I know for a fact that it's just going to be x plus or minus, probably plus, negative, whatever, b over 2. So I don't have to think about it. I'm just going to write x. And in this b is b over, okay, I should be really careful about this. B was actually negative 118, and b over 2 is actually negative 59. But when I square it, the negatives went away. So this is a minus 59 quantity squared. And I could check that x times, if I was going to check it, and I probably would, x minus 59 times x minus 59, I would have first would give me x squared. Outside and inside are the same, so it's 2 times negative 59, so that's negative 118. And the last would be positive 3481. So that is correct. That is not quite vertex form, because vertex form I have to have everything equal to 0. So in the end, vertex form gives me 0. I'm going to add 36.81 to both sides. I'm going to have negative 0.01 times x minus 59 quantity squared plus 36.81. I write scrunchy when I'm running out of room. So that is vertex form. And just by looking at that, I can see that my vertex is the negative of, all right, well, it's positive. I just ignore the minus sign. So I've got 59 would be my horizontal distance, and 36.81 would be my vertical distance. So the answer to the question, what is the maximum height, would be 36.81. And all this time we've been working in feet, no conversions. So that's the first one. You can keep watching. All right. So the nearest defensive player is 5. I'm going to need like tons of that. I'm going to need that equation, that's for sure. I have a touch screen here, but that worked. You can see I've got it set up different than I've got it set up at school. Whatever. What was it? Negative 0.01 times x minus 59 plus 36.81 equals 0. Okay, so the nearest defensive player is 5 feet horizontally, so that means in the x direction, we've got kicker boy over here, ball after 5 feet. Ooh, linebacker guy, they don't jump, they just throw their arms up in the air, is 5 feet away. How high must he reach? Okay, well, let's assume his arms are over his head. How high must he reach to block our punt? So what that means is, what is find y when x equals 5? So that's, I would probably put that into the original equation, frankly. But you have a calculator, so I'm not even going to do it for y'all. I'm just going to write it out, because there's no point you watching me punch in numbers, for goodness sakes. Plus 36.81. I am going to do it. I'm curious now. So we've got, let's even let you see. Okay, we've got negative 0.01 times 5 minus 59 plus 36.81 squared. Whoops. Which is, this is good. You can see how, I make a lot of mistakes. There's a lot of cool things on this calculator. If you hit second enter, it'll give you back what you did before. And you can go over and insert something you missed. So that should do it. Okay, that makes sense. You should always check your numbers to see if they're possible. So what we're getting is that blocker guy has to be able to reach 7.65 feet to block the ball, which if he's 6 feet tall is distinctly possible. And if the ball kept going, okay, so this goes way back to the first thing. They're asking you, how far is this X distance? And that means what that basically means is that we have to find our X and our Y intercept. That doesn't make sense that I said that. We have to find out what is X when Y equals 0, which we can do. But I'm going to pause right now because this is the first part of this, and I don't want to, if I screw up, I don't want to have to do the whole thing again. So we're going to call that a momentary pause.